Scientists believe time never changes, forever constant. They trusted time proceeds at a constant rate throughout the universe, regardless of external forces or position. So they thought time travel was scientifically impossible. That is, until a 26-year-old Albert Einstein came along. In 1905, Einstein proclaimed time is pliable and depends on speed. He suggested that time can slow or hasten based on an object's velocity. It wasn't until 1971 that Einstein's ideas on time could be experimented. Initially, 8 atomic clocks were created. 4 were placed on the ground and the other 4 on an airplane, traveling worldwide. This was a relatively simple experiment to compare the two groups' times. Scientists compared the time of the atomic clocks installed on the airplane upon its return with the atomic clocks installed on the ground. The findings confirmed that the atomic clocks on the airplane ran slower than the other on the ground. It was a pivotal moment that validated Einstein's theories. Time travel, as demonstrated by this experiment, is feasible and has actually happened repeatedly in the past. Traveling at nearly 27,000 kilometers per hour in space for 879 days, astronaut Gennady Padalka returned to an Earth that was a future ahead by 1/44th of a second. Yet, a future advanced by 1/44th of a second is virtually imperceptible. Then what would happen if we could move much faster than this? I'm not speaking of jets or rockets, but of something else that can attain 299,791.819 kilometers per second. In fact, moving into the future has been happening since ancient times at the atomic level. This is seen in Large Hadron Collider and similar devices. These devices send subatomic particles into the future with each experiment conducted. Particle accelerators can accelerate protons up to 99.999999% of the speed of light. Accelerated protons experience time dilation, flowing about 6,900 times slower than our observed time. In essence, while 6,900 seconds elapse in our time, only a single second passes for the protons. Humanity has been sending particles into the future for a long time. This concept can easily explain human time travel. If you wish to explore the Earth 1,000 years hence, just speed up a spacecraft to 99.995% of light speed. Traveling aboard the spaceship to a planet like Kepler-186f, located around 500 light-years away, you would arrive in approximately 500 years due to the ship's near-light speed. After a quick meal and rest there, if you resume the journey, you would also reach Earth in approximately 500 years. So, the round trip to Kepler-186f, including the time spent going and coming back, would take about 1,000 years. And thus, after 1,000 years have elapsed, the time on Earth would have reached the year 3020. However, for people inside the spaceship, time passed at a speed of 1/100th that of the Earth's time. Due to the spaceship they were aboard moving at nearly the speed of light, time flowed relatively slowly for them. Thus, while 1,000 years passed on the Earth, the time experienced by the people inside the spaceship was only about 10 years. Even if we were to explain to them that they had traveled for 1,000 years, they would never believe it. Surely, there will be a very big difference between theoretical and practical aspects. How can we overcome the technical challenges required to construct a time machine? There are indeed numerous obstacles in the development of a spacecraft capable of time travel. Firstly, we lack the technology to create an engine capable of traveling at the speed of light. The fastest spacecraft built by humans is the 2018 launched Parker Solar Probe, which can reach speeds of about 0.00067% the speed of light. Furthermore, there is a lack of the immense fuel needed to accelerate a spacecraft to the speed of light. To make this possible, highly efficient antimatter fuel can be crucial. Many scientists believe that this type of fuel will play a vital role in interstellar travel. To undertake such missions, survival-related issues like food and medication must also be resolved. Furthermore, the theory of time travel has one disappointing problem. According to scientists, time machines are believed to be able to travel to the future but not to the past. To resolve this issue, scientists have proposed solutions like wormholes, black holes, and cosmic strings as possible means to travel to the past. Wormholes, capable of connecting points in two space-time, are particularly noteworthy. Furthermore, it is quite appealing that wormholes do not violate the scope of Einstein's theory of relativity. However, scientists have not yet discovered wormholes. In fact, there is no clear evidence that wormholes can guarantee time travel to the past. Therefore, while time travel to the past may be an intriguing concept, it remains theoretically impossible at this point. As a result, scientists are now focused on researching ways to travel to the future rather than the past. In the distant future, it is certain that we will be able to create a time machine. There is a possibility that the timeline could be advanced further through unknown discoveries yet to be made. It is also possible that even the currently deemed impossible travel to the past could become achievable in the future. Contrary to our expectations, time travel may not be invented after all. However, through these challenges, we will gain a deeper understanding of the universe.